Hi, welcome back. In this video, we will be talking about how do you simplify a rational expression when you're multiplying or dividing them. In future videos, we'll talk about adding and subtraction, but for this video, it'll be solely on multiplying and dividing. So let's do an example so you can see what we're talking about here. So here we have a rational expression. What makes it rational? Well, we have a fraction multiplied by another fraction, right? If you rather change these variables to x's, you can do that. But what I'm going to be doing here to simplify the rational expression is that I'm going to multiply things, combine like terms, and simplify this as much as possible. To do that, I'm going to start by factoring. I'm going to factor the numerator, right? We have y squared minus 16. To factor that, you can add a 0 in the middle if you prefer. And you can do the 3-column method that we've been talking about in this class, where you multiply y times y, and then 4 times 4. And then as you cross multiply, you get 4y, you get 4y, and the only way to subtract them or to get a 0 is if you subtract these two, which means one of them has to be negative, right? So the factors here are y minus 4 and y positive 4. So I'm going to rewrite the numerator as the factors, y minus 4 and y plus 4. I'm going to do something very similar with the denominator, right? I can do the 3 columns if you want, as long as I add the 0 in the back to get my third term, my c term. And then I can do y times y, and 0 times any number is going to give me 0. So if I'm going to be cross multiplying, this gives me 0y. What times y will help me get a 4 here? And that's 4, right? 4 times y is 4y. And the only way to make this a negative 4 in the middle is if I make that a minus, which means my factors are y plus 0 and y minus 4. Now, I don't really have to add 0, so I'm going to just leave it here as a y times y minus 4, because adding and subtracting 0 doesn't change the value of y. On the right side, there's nothing to factor. It's just y divided by y plus 4. And as you do with regular fractions, whenever you multiply fractions, you multiply them horizontally, right? You multiply the numerator by the numerator and the denominator by the denominator. When I do that, I do, on the top I have y minus 4 times y plus 4 times y. And in the bottom I have y times y minus 4 times y plus 4. Right? Here I factored the problem. I factor the quadratics, and then here I'm going to simplify. Notice how y minus 4 divided by y minus 4 cancels to 1. The y plus 4 also divide, and then the y's also divide. Anything divided by itself is just 1. So we were able to simplify all of this by factoring, combining like terms, and get the value of 1. Right? So we can actually break down this problem into 2 steps. Can you factor anything quadratic or cubic related, and then can you simplify the problem? So let's do another one. Let's do a division example, and then we can always come back and do multiplication some more. Right? I'll do a multiplication and a division, and if you want to go beyond that, you can always come back and do a multiplication and a division for more practice. Now, when you're dividing fractions, you might recall keep, change, flip. Right? Anytime that you're dividing two fractions, like something like this. Right? Think back to middle school, elementary. When you're dividing, you're going to keep this the same. You're going to change the sign to multiplication, and then you're going to flip the second one. And when you do that, you can actually multiply across, right? 1 times 3 is 3, and 2 times 1 is 2. So dividing fractions is really similar to multiplication. If you change the sign, and if you flip the fraction, it now becomes a multiplication problem. And we're going to do the same thing here. We're going to keep this fraction the same, change it to multiplication, and then flip this other one. x plus 3 on top, and x plus 2 in the bottom. Now, just like we did it earlier with multiplication, we wanted to factor the quadratics. So we're going to factor this piece right here. Let's factor the top. X squared plus 5x plus 6. When I factor, I have x times x, and then 2 times 3. Right? Because when I cross multiply, 3 times x gives me 3x, and then 2 times x gives me 2x. And that certainly adds up to 5. So what are my factors? X plus 2, x plus 3. We're just rewriting the problem in factored form because, as you can see, we can start to find some similarities. It's harder to look at the similarities between a quadratic and a binomial, but when it's in factored form, I can find more similarities like that. And that's really the goal. Can we find similarities between the two fractions when I multiply them and divide them? For the denominator, you got x squared plus 0x minus 9. You can add that 0 term in the middle, which gives me x times x and 3 times negative 3. Right? They have to be opposite in order for them to cancel to 0 here in the middle. Right? 3 minus 3 or negative 3 plus 3. So what are my factors? I got x positive 3 and x minus 3. So I factor the problem. Now I simplify. So let's multiply the fractions. Just like we did here, right? We multiply the numerators, we multiply the denominators. Do the same thing here. Multiply the top, we get x plus 2 times x plus 3 times x plus 3. And in the bottom we have x plus 3 times x minus 3 times x plus 2. And as you can see, a few things will start to divide and cancel out, like the x plus 2's cancel, and these x plus 3's cancel. Leaving me just with x plus 3 in the numerator and x minus 3 in the denominator. And I can't divide any further because the top is grouped and the bottom is grouped, so I can't cancel the x's or anything else. So division is really just multiplication. If you change the sign, you have to flip the fraction. And then you can just multiply sideways like we did before. If you felt that this has helped you, don't forget to like and subscribe. If you want to stay here for more examples, feel free to stick with me and we can do a few more examples together. So let's talk about another multiplication example. And then I can do another division example. And if you feel comfortable, you can sign off. All right, let's factor here. We're going to factor the problem. On the top, I got 3x squared minus 12x. I'm going to add a 0 at the back so that I have my 3 terms. 3x times x, and then 0 times anything will give me 0. Now, I'm going to want to multiply this by 0x. Something times 3x will help me get to the 12. Right? 4 times 3 is 12x. How do I make this one a negative 12? Well, for this to be negative, I need to make that negative. Right? 3 times negative 4 gives me negative 12. So what are my factors? 3x plus 0 and x minus 4. Now when I rewrite this, I'm not going to put the 0, I'm just going to put the 3x. Right? How do I factor the next piece? X squared plus 0x minus 4. Right? Since they're both perfect squares, you can just square root them, right? It's going to be x and then 2. Just make one positive and one negative. That way when you cross multiply, they cancel the 0. Right? That's the goal here. So I have a positive 2 and a negative 2. Right? First step, factor. Second step, let's combine the two fractions by simplifying. Let's multiply them together. On top, I will have 3x times x minus 4 times x plus 2. And in the bottom, when I multiply everything, I'll have x plus 2 times x minus 2 times 3x. And as you can see, the x plus 2's are going to cancel, and the 3x's are going to cancel. leaving me just with x minus 4 divided by x minus 2. That's as simple as I can make it a problem. Alright, you ready for the last example? Whenever you're doing these videos, I strongly recommend that you pause the video and then give the problem a try. And then press play and see if you get the same solution that I do, right? Alright, we're going to start by keeping this the way that it is, changing it to multiplication, and then flipping the last one, the last fraction. And I start with that step. Change it to multiply and then flip it. Z plus 2 and Z minus 3. So let's factor here. Right, this is the change part. So if I factor the top, I get Z squared minus Z minus 6. Here I will have 3 times 2. Now as I cross multiply, the only way to get a negative Z from here is if I do 2 minus 3. That way that becomes a negative 3. So my factors are Z minus 3 and Z positive 2. And the bottom, what are going to be my factors? I have a 0 in the middle, right? What's going to multiply to get 9 but cancels a 0 in the middle? Z plus 3 and Z minus 3, right? Now if you want to see it, you can put it here on the side, 0Z minus 9. Z times Z is Z squared. And 3 times negative 3, that's what's going to cancel, right? That's what's going to cancel to get the 0 in the middle. That's how I got Z plus 3, Z minus 3 from here. Alright, last step. We simplify by multiplying the actual fractions. I've already done the keep, change, flip part here. So let's multiply them together. Yeah. On top I have Z minus 3, Z plus 2, and Z plus 2. In the bottom, I got Z plus 3, Z minus 3, and Z minus 3. Let's now see what divides and cancels out, right? The Z minus 3s are going to cancel. I believe that's it. Nothing else cancels or divides. So I'm left with Z plus 2 times Z plus 2 divided by Z plus 3 times Z minus 3. You can leave the solution like this, or you could even condense this further. Since I can't simplify and cancel anything else, let's condense the solution further. So I have 2 of these Z plus 2s. So I can say that's just being squared. And then the bottom, what's Z plus 3 times Z minus 3? What do we get when we multiply those? Well, if you do FOIL, Z times Z is Z squared. Z times negative 3 is negative 3Z. 3 times Z is positive 3Z. And 3 times negative 3 is negative 9. These are going to cancel, leaving you just with Z squared minus 9. And if you remember, that's where this came from, right? Z plus 3, Z minus 3. So I can write this as Z squared minus 9. Both of these are acceptable solutions. One of them is just more condensed. But it's the same values, yeah? Alright guys, I hope this has helped. Please let me know if you have any questions. Don't forget to like and subscribe. And as always, we'll calculate.